Hi, so today we're gonna do this question called as the most frequent subtree sum. Question goes like, to given the root of a tree, you are asked to find the most frequent subtree sum. The subtree sum of a node is defined as the root itself and the sum of the roots. So there are and if so what is the other cat? So what if the most frequent subtree sum value, and if it's a tie, return all values with the highest frequency in any order. So this any order kind of says, okay, order is not an important factor here. So let's try and decode this part. All right, so we've got 5, 2 and minus 3 as a tree, right? So I'll take this. Okay, so I've got 5, 2 and minus 3. This is my tree. The first step in any kind of a question related to trees is to figure out the recursion, right? So what you see here is the sums that I'll get is 2 minus 3 and 5 plus 2 7 minus 3 4, right? There are three total type of sums that I can get. That is the sum of these three, this individual node, this individual node, and this. So whenever trying to figure out recursion, so luckily in this question we are only given this small tree, so it's kind of easy to figure out the recursion. So obviously whenever trying to figure out obviously the first thing would be, you would say if root is null, return 0, right? Now the other thing is, we know that whenever there's a leaf node, that itself has, you have to add the sum here. It's a type of a sum, so we can say if root dot L and is equal to null and root dot R equal to null, add that as well to the sum, right? That's also a sum. Then the other thing is, for this particular node, what is the sum? It's the sum of this particular value plus the left subtree and the right subtree. So I can say here int sum equal to root dot val plus solve. Go ahead and solve and get me the sum of the left subtree plus the root solve of the right subtree, right? That would give me the sum here, and we would return sum again from here at the end of the method. The reason, now let's say I have this tree 5, 2 minus 3, I have another value 3 here and 6, right? Now we know that the sum of, so here it's 2, here it's minus 3, and when the recursion is here, it's gonna say, okay, the sum of these three is 4, and 3 is gonna be like, hey, what's the sum of the left and the sum of the right? Okay, so that's why we need to keep returning the sum. Now one of the other catches of this question is we need to find the most frequent sum, right? So I've got 5, 2 and minus 3. This is my tree. Now how do I track these values? The first question thing that comes when it says, and it says there can be multiple types of sums. What if you have 2 plus 2 plus 2 2? Now you have 3 and you have 0, right? There are 3 2 0 2 comma 2 comma 2. Now the best way to store these kind of sums, the first thing that will come to your mind is a map, right? So obviously I'll store, that would be a sum by the count of these sums, that the number of times it has appeared, right? So you're gonna store that using a map. Now if you see the code, this is how I have solved it. So I've declared a global variable called map, which is a sum by count, and and I call the solve. The first thing I do is check, okay, if it's null, then I'm going to return an empty array, right? There are different ways to do this. This is not the most efficient. It's all right. The priority queue stuff, we'll get to it. That's the next part. So the next part is I say solve, go solve the root and come for me, which will populate this particular map for me, right? So if you see, if root is null, I return 0. If root is left equal to null, or and right equal to null, sum by count, get default values. This is a very powerful technique for maps. You can just get the value and you can put it, and you can just return the root dot val here, the value of the root. So if it's 5, 2 and minus 3, I'm going to return, hey, you know what, the solve of this thing was 2 and this thing was minus 3. I have to return that. So this is the recursive part. So the sum is the value at that node plus, hey, what's the sum of the left subtree and the sum of the right subtree, correct? And if you want to pan out this recursion, okay, so let's say I've got 5, 2 and minus 3, right? Now my code is like, if root equal to whatever. So the main, so let's just take this. I'm gonna say, hey, you know what, sum, we're gonna just solve it to the fifth one. So sum is root dot val and solve of root dot left and root dot right? So int, so sum is equal to root dot val, root dot plus solve root dot left plus solve of root dot right? So obviously it's going to be 5 plus solve of 2 plus solve of minus 3. Okay, so this is where the recursion is going to go. And obviously we have a condition which says, okay, if you're a child node, just add it to the map and return it. So if you see, our map will be like 2, 1, minus 3, 1 and 4, 1. That's our map. Now I have got all of these as stored in my map. The difficult part about a map is that you cannot sort it key wise or value wise, so that's where the priority queue comes into the picture. And priority queue or max heap, the way you want to use it. This particular piece of code, this is a technique that I have invented personally. So whenever I want to sort anything by value, I just push everything to a priority queue, and the priority queue will just give me the largest value, right? So this particular code says entry of integer comma integer. That's my map. Every entry on my map is going to say that. And priority queue, and this comparator here, if you do b dot get minus value, so this thing actually can boil down to, you can say return of a dot get value greater than b dot value greater than b dot get value, then question mark, obviously, then return 1, or else a dot get value equal to b dot get value, then return 0 or else minus 1. So this says whenever b is greater than a, that's of a higher priority than this. So if we try to re-equate this equation, we would get back to this, right? Then what do? Is we push everything off that sum by count. We take all the entry set and we offer it to the queue. We push it into the queue. Now since that queue has these kind of values, now I need to find out all the ones that have, so the largest, if this was a 4, my queue would sort it by the values and it would return me the 2 first, the highest frequency, and I would know that the highest frequency is 4 because of the value here. So that's the reason we end up checking, hey, you know what, get dot answer dot add and key hey, so the max value is obviously going to be the front of the queue, and we add it to our answer list. And while the queue is not empty, this is because so that we can avoid some null pointers into this, and I get answer value, and if at any time it's not equal to the max value dot get value, break out of that loop, stop it, so if I'm going down this particular thing, I'm seeing, hey, if this is a 4 and a 4, I'm going down this particular thing, I'm saying, hey, what the value is for the number of occurrences was, the largest one was 4, the next one is minus 3, next one is also 4, the value, the key is minus 3, so I'm going to keep inserting those keys, and the last one is 1, so 1 is not equal to 4, and that's the reason we end up breaking out of this loop here, right? And then obviously we just convert it into an array because this thing requires the answer into that array. That's how we solve LeetCode 508.